7, 8, and 9, and probably a lot of the rest ones, are finding limits when I have a function on here. So I'm going to find the limit as x approaches 1. If the limit does not exist, I'm going to put does not exist. So we want to use the limit laws. So I'm going to go over here and bring up my limit laws. Again, if you go to the dictionary and type in limit laws, you can print out this page or bring up this page. So if it says I'm finding the limit as x approaches a for c, and c is a constant term. So for example, if I am finding the limit as x approaches 2 of 3, my answer is just going to be 3. That's what that's saying, is if I have a constant there, the limit is always the exact same number because I'm always going to have 3's. The second one says if I have the limit of x approaches a of just x, I'm going to get an a. If I have the limit of x approaches 2 of x, what I'm doing is I'm putting 2 in for the x, and so my answer is going to be a 2. If x were 5, I would get 5. Various things. Now these rest of these first ones are kind of weird. All they're doing is saying that if I have a function and I have f of x and g of x, I can find the limit of each part of that separately and then add my answers together. So on the third one there, if I would have something like the, well, it's going to write eventually here. Let me see if I can get it to work. The little thing wants to spin. Didn't like me using the eraser. If I would have the limit as x approaches 2 of 2x plus 3x, that I would find the limit of this and the limit of this and add my answers together. Well, if I'm going to find the limit of 2x, I'm going to take 2 times 2, which is 4. If I'm going to find the limit of 3x, I would take 3 times 2, which is 6, so my limit ends up being 10. So it's just saying, oh, I could split them apart and find the limit of each of them separately, and then I get my answer. Same thing with number 4. If I'm subtracting, I can find the limit of each part and subtract them, and that's going to give me my answer. Number 5 is if it's multiplied by something. So same kind of thing. I would find the limit of it, and then I'd multiply it by some value. If the two things are multiplied together. Now number 7 is one that's maybe a little more important to look at, because basically it's a little different than, well, it's not really a little different, but it's important. If I have a fraction, normally I would find the limit of the top, the limit of the bottom, and then divide my two answers. But what I have to be careful of on my fraction is that my denominator is not 0. We know that division by 0 is undefined. We're going to have a whole bunch of them where the bottom is 0, and we have to take a different approach to finding the limit other than just plugging the number in and solving. And then we get back to, okay, if I raise to a power, if I'm going to do the square root, if I again have something, a constant term raised to a power, and a square root. So most of them, when we evaluate a limit, all we're really doing is substituting the number that it approaches in for the x's and solve it. The only one we have to watch out for is when we have division by 0, and then we have to take a different approach to solving the problem. So those are your limit laws. Nothing that you have to memorize. They're really not that important, other than when you get to the ones with 0 on the bottom. So for most of your limits, if you're going to find the limit of a function as x approaches 1, all you're going to do is put 1 into the function and solve it. So I'm going to find the top and the bottom. So I'm going to take 3 times 1 squared minus 4 times 1 plus 3, and then the bottom 1 minus 6. So here 1 squared is 1, 3 times 1 is still 3, negative 4 times 1 would be minus 4, plus 3. 3 plus 3 is 6, 6 minus 4 would give me 2. On the bottom, 1 minus 6 is negative 5. So my limit as x approaches 1 of this function is going to be negative 2/5. Same thing on number 8. All I'm really going to do to find the limit as x approaches 3 is to put 3 in for my x's. As long as the denominator is not 0, we're good. So I'm going to start by doing 3 cubed plus 8, and then I'm going to take 2 times 3 minus 5. 3 cubed is 27. 27 plus 8 would be 35. On the bottom, 2 times 3 is 6. 6 minus 5 is 1. So my limit as x approaches 3 would be 35. Number 9. Here we're finding the limit as x approaches negative 3. Same thing, I'm just going to plug it into my expression. As long as the denominator is not 0, we're all right. So we're going to take 3 times negative 3 plus 3. On the bottom, 3 times negative 3 squared plus 2 times negative 3 minus 9. So 3 times negative 3 would be negative 3, or negative 9. 3 times negative 3 is negative 9. Negative 9 plus 3 would be negative 6. On the bottom, negative 3 squared would be 9. 3 times 9 is 27. 2 times negative 3 would be minus 6 and minus 9. So 27 minus 15 would give me 12. Well, if I have negative 6 over 12, it reduces down to negative 1/2. So my limit as x approaches negative 3 would simply be negative 1/2. So first, easiest way of finding my limit of a function is just to put the number in for your x's and evaluate the expression at that value.